Lesson 6.1. As we begin this new unit, let's review what we know about exponents. When we read this power, this m to the third is called a power. The whole thing is called a power. We read this as m to the third. Our m is our base, and of course the 3 is our exponent. And an exponent tells us how many times to multiply the base by itself. So m to the third communicates multiplying m times m times m 3 times. Just as x to the fifth would communicate multiplying x by itself a total of 5 times. Or, for example, 3 to the third times a to the fourth. That communicates 3 threes times itself, and a times itself 4 times. So an exponent tells us simply how many times to multiply the base by itself. Hopefully, in the activity that you did in Lesson 6.0, you began to realize some patterns as you looked at those exponent examples. We have a product of powers property. Remember, product is the answer to a multiplication problem. So hopefully what you began to realize is this, that to multiply exponents with the same base, you simply add the exponents. In fact, as I say that out loud, let's change that and say to multiply powers with the same base. You add their exponent. Let's correct that word. To multiply powers with the same base, you add their exponents. Let's consider that rule with these examples. In number 1, it says x to the second times x to the eighth. So we have a multiplication problem. We notice that both of our bases are x's, so the rule says let's add our exponents. So we add 8 plus 2, and we get x to the 10th power. Number 2 says a to the fourth times a to the ninth. Now we have to remember that when we have a number or a letter by itself with no exponent written in, there's an understood exponent there of 1. So it's often helpful if we just take a moment and write that in. This is a to the first times a to the fourth times a to the ninth. Notice again, all the bases are the same, so we're going to add 9 plus 1 plus 4, and then we'll rewrite that as a to the 14th power. Now, take a look at number 3. Let's break that down a little bit further. It's 2 to the fourth times x to the third, right? Number next to a letter communicates multiplication, times 2 to the first, remember there's that understood exponent of 1 there, times x to the fourth. Now the rule says that we can add exponents if the bases are the same. So let's consider we have a base of 2 and another base of 2. If we add those exponents together, we get 2 to the 5th power. 4 plus 1 gives us 5. Then if you notice, we have a base of an x and another base of an x. Let's add those two exponents. 3 plus 4 gives us 7. So we have 2 to the 5th, x to the 7th power. Notice that I only added the exponents when the bases were the same. I didn't go through and add every exponent in that problem. I found the like bases. I added only those exponents. Let's consider the second rule that you learned in Lesson 6.0. This is the quotient, so division rule. To divide, and again, let's make a change here. To divide powers with the same base, we subtract their exponents. So in lesson 6.0, that activity, you saw a pattern there that when we have a division problem and we end up crossing out exponents, we subtract the exponent. That's a much faster, more effective way to do that. So let's look at some examples of number 4. It says x to the 11th divided by x to the 3rd. Notice that our bases are both x, and so we can subtract the exponents to make that x to the 8th. Number 5, we have 7 to the 9th and 7 to the 6th. We subtract the exponents and get 7 to the 3rd. Number 6, we have m to the 7th times n to the 5th divided by n to the 3rd. Notice here we have a part of a division problem. Both of the n's are the same bases, so we can subtract and we get n to the 2nd. Now that m to the 7th just remains as part of our answer. We don't get rid of it. We don't subtract it with the other ones because it has a different base. We just keep it there as part of our answer. Then we learned hopefully a third and final rule in the activity in lesson 6.0, and that rule says that sometimes we distribute with exponents. When we have in parentheses a power, and then we have an exponent on the outside of the parentheses, we apply the distributive property. We say 3 times 3, and we make that a to the 9th. So let's look at a few of those examples. Number 7, we have 5m to the 3rd, all raised to the 2nd power. Now let's remember what I mentioned earlier. Anytime we have a number or a letter without an exponent written, it's understood that there is a 1 there. So let's go ahead and write in that understood 1. Let's make that 5 to the 1st. Now we're going to distribute exponent to exponent. 2 times 1 is 2. That becomes 5 to the 2nd. 2 times 3 is 6. So that is m to the 6th. Notice how I distributed the exponent on the outside to every exponent on the inside of the parentheses. Number 8, we have 3 to the 1st, a to the 2nd, b to the 1st, c to the 3rd. Let's distribute exponent to exponents. 1 times 4 is 4, giving us 3 to the 4th. Let's distribute again. 4 times 2 is 8, giving us a to the 8th power. 4 times 1 is 4, giving us b to the 4th. 4 times 3 is 12, giving us c to the 12th. Our last and final example. We have brackets, works just like parentheses. Let's distribute. We have 4 times 5, giving us a to the 20th. We have 4 times 3, giving us b to the 12th. The key here is that we always distribute an exponent on the outside of parentheses to every single exponent on the inside of the parentheses.